Welcome back. In this video we're going to explore the second derivative test. The second derivative test continues to describe the original graph. We talk about concavity, concave up, concave down, and then points of inflection. With the second derivative, if the second derivative is positive, then the graph is what we say concave upward. I'll show you a picture of this in just a moment. If the second derivative is negative, we say it's concave downward. Where the concavity of the graph changes is what we call a point of inflection. So what you're going to do in these problems is you're going to find the second derivative. You're going to set it equal to 0. Where the second derivative is equal to 0 or undefined, those are possible points of inflection. It's only a point of inflection if it changes concavity. So right over here, this would be concave up. The water would stay in the graph. This would be concave down. The water would spill out. Where that concavity changes is called a point of inflection. This is a picture of the original graph, If there's no change in concavity, it's not a point of inflection. The second derivative will also help us find maxes and mins, because if at a critical number, in other words, where the first derivative equals 0 or is undefined, if the second derivative is negative, that means it's concave down, which means that critical number has to be a max. If the second derivative is positive, that means it has to be concave up, and that means it has to be a min. I'll show you an example of this in just a moment. So in this first example, we're looking for our extrema of the function, and then we're going to talk about points of inflection, concavity. So in this particular case, we find the derivative, f prime of x, which is going to be 4x minus 4x cubed. We're going to need to describe the extrema, so I need to solve that. So I'm going to factor out a 4x out of that, and I get 1 minus x squared. I have possible maxes and mins at x equals 0 and x equals plus or minus 1. If I find the second derivative, 4 minus 12x squared, if I solve that, I get possible points of inflection at plus or minus the square root of 1/3. Don't need to simplify that. Draw your number line just like you did with your first derivative test. Put in negative square root of 1/3. Put in positive square root of 1/3. And then you're going to do your sign chart just like you did with your first derivative test, but this time you plug in the second derivative. So like if I try something below here, say -1, if I put -1 in there, I'm going to get a negative. If I put 0 in there, I get a positive. And if I put 1 in there, I get a negative again. So the way we write this is we do have these changes in concavity. It's concave down, concave up, concave down. These points are points of inflection. And then when I describe the extrema of the function, 0 falls in this interval. So 0 has to be a minimum value because it's concave up, means it has to be at the bottom. When I do -1 and I do +1, that's concave downward, so those have to be maximum points. So here we go. Concave down on the interval from negative infinity to negative square root of 1/3, and we never include, with concavity, we never include the endpoints. Union with positive square root of 1/3 to infinity. It is concave up on the interval from negative square root of 1/3 to positive square root of 1/3. We have points of inflection at x equals plus or minus the square root of 1/3. And then extrema, we have a local maximum values, two local maximum values at x equals plus or minus 1. And then we have a local minimum value at x equals 0. So our second derivative test can help describe the graph quite a bit. Continue on with that. Again, another polynomial function. So we got to find our first and second derivative. We're going to do concavity, points of inflection. So first derivative is 3x squared minus 12x. Second derivative is 6x minus 12. That equals 0 at 2. So I set up my number line chart, put in 2. When I put in my test values, I put them in the second derivative. So if I plug in 0 over here, I get negative. If I plug in 3 over here, I get positive. So I'm concave down on the interval from negative infinity over to 2. Concave up on the interval from 2 to infinity. And I have a pi at x equals 2. Be careful. Sometimes you have things like this where they give you a first derivative and they ask you the x coordinate of points of inflection. So I've got to find my second derivative, which is going to be 12x cubed minus 36x squared. I need to set that equal to 0 and solve it, so I'm going to factor. So 12x squared times x minus 3. When I have my possible points of inflection, that are going to occur at 0 and at 3. Now, when I go to plug in into my second derivative, I do my test values, I can forget about this 12x squared because it's squared, it's always going to be positive. So if I plug in like -1, I can just plug it in right here, and that's negative. If I plug in +1, it's still negative. And if I plug in 4, I finally get a positive. Now, the only change in concavity occurs at 3. So even though 0 is a possible point of inflection, it's not a point of inflection because there's no change in concavity. So only at x equals 3 is there a change in concavity. So that is my only one where I have a point of inflection. So I have a pi there. And then the other one that I see sometimes is I'll see them give you something like this with a calculator. They give you a second derivative, sine of 3x minus cosine of x squared, and they ask you how many points of inflection on the interval from 0 to 3. So we pull out our calculator. We're going to go ahead and put this in. We change our window from 0 to 3. We go from -1 to 1. We get a picture of it. It draws our picture of it. Now, right in here, remember there needs to be a change in concavity. So where the second derivative is negative, it's concave down. Looks like it goes positive. We're going to zoom in on that, and then it's negative, positive, so on. So I think there are 5 changes in concavity, but let's zoom in right here. Let's change our y maximum value to 0.5 just to make sure there's a change in concavity there. It definitely goes above and below. So there are 5 points of inflection. If they asked you where they are, then you'd have to calculate them. But in this case, they just ask you how many there are. So there are 5 of them. All right, we'll see you in class. Clarify. Good luck.